Hello everyone, good evening. So here we shall solve some KCET previous year questions on the chapter Matrices and Determinants. So any doubts if you have in the steps, then please write that in the comment section. And in any other chapter of maths, if you feel more difficulty, then also please mention the name of that chapter in the comment section. Then we shall give more priority on it and solve more and more questions on that chapter. Also, please install our Sapience Education application, where we shall upload some important homework questions on every chapter, which shall be helpful for your KCET exam. So let's start with the very first question onwards. So in the previous two parts also, we had solved some questions on this chapter. In those questions also, if you have some difficulty in understanding, then please write that in the comments section also. We shall obviously clarify those any doubts which you have. So here it is told that if the matrix 2x, we have to find the matrix x if 2x plus 1, 2, 3, 4 matrix that is equal to 3, 8, 7, 2. Okay. So now therefore the matrix 2x can be written as what? 3, 8, 7, 2 minus 1, 2, 3, 4. Okay. So therefore 2x can be written as, so 3 minus 1 that is 2, 8 minus 2 that is 6, 7 minus 3 that is 4, 2 minus 4 that is minus 2. Okay. So therefore x will be half of this. It means that half should be multiplied with every element. 2, 6, 4 minus 2. So that will be 1, 3, 2 minus 1. Okay. So option 1 is the correct answer. Then here it is told that we have to find the value of this. So it is told that we have to find the value of the determinant, the determinant of 1, 1, 1, B, C, C, A, B, then B plus C, C plus A plus B. We have to find the determinant of this. So here what we can do, we can multiply all the elements in the second row with, okay, or first we can multiply the elements of the first column with A, the elements of the second column with B, and third column with C. So it means we can multiply and divide by ABC. So ABC by ABC times 1, 1 times the determinant of 1, 1, 1, B, C, C, A, AB, and B plus C, C plus A, and A plus B. So then one of this A, I can multiply it with the first column, B with the second column, and C with the third column. So then we will get 1 by ABC times the determinant of A, ABC, then AB plus AC, then this will be B, ABC, then it will be BC plus AB, then this will be the third column I will multiply with C, so that will be C, ABC, then AC plus BC. So then from the second row, I can take ABC as common outside. So this will be ABC again by ABC. So that will be A, B, C, and then it will be 1, 1, 1, and this will be AB plus AC, BC plus AB, and AC plus BC. So then these two will get cancelled, ABC and ABC. So then what we can do, we can then subtract the column 1 we can do column 2 will go to C2 minus C1, and we can also do C3 goes to C3 minus C1. So if we apply this column operations, then we will get this will be equal to the determinant of A1 AB plus AC. Then here it will be B. So this is okay, we can write it in the next slide. So this will be then equal to, this will be the determinant of A1 AB plus AC, and this will be B minus A. This will be 0, 1 minus 1 is 0, and BC plus AB minus of AB plus AC. So this will be BC minus AC, BC minus AC, and this will be again C minus A, and this 1 minus 1, that is 0. This will be AC plus BC minus AB minus AC. So this will be BC minus AB, BC minus AB, the determinant of this. Okay, so this will be, now we can expand this along the second column. We can expand this determinant along the second column. So this is the element of the second row and first column. So this will be minus 1 into, we have to exclude the second row and the first column. So this will be this minus this times this into this minus this. Okay, this will be B minus A into BC minus AB minus BC minus AC into C minus A. So this will be minus of this. So I can write C minus A, C minus A, and here I can take C as common. So this will be C into B minus A. Then minus this will be B minus A. And from here B I can take as common. So B into C minus A. So this will be, from these two I can take B minus A into C minus A as common. Then it will be C minus B. So this I can also write it as A minus B into B minus C into C minus A. Since minus of minus, that is plus. Okay. So this is the answer. So I can say that option 3 is the correct answer. Okay. Then here it is told to find the value of this determinant. So the value of this determinant, that is 441, 442, 443, and this is 445, 446, 447, 449, 450, 451. Okay. So here we can see that these three terms are in AP. These three terms are in AP. It means they are in the arithmetic progression, since their common difference is 1. So then what we can do, we can do C1 goes to C1 plus C3. If we apply this column operation, then this will be equal to the determinant of, so be 441 plus 443. So this is 884. So 442. So this is 443. So this will be again 12. So 490. So 892. And this will be 446. This will be 447. So then we can do 800 and be 8. Sorry, this will be 900. Okay. This will be 900. This will be 450. 450, that is 451. So here we can see that the first column and the second column are proportional. So if we subtract, if we do C2 goes to C2 minus, means if I do like this, if I do, then next if I apply the column operation, that is C1 goes to C1 minus 2 C2. So then all the elements in the column 1 will become 0, 0, 0 and 0. Then 442, 443, 446, 447, and this is 450, 451. So here, since all the elements in the column 1 are 0, so the value of this determinant will become 0 only. So option 2 is the correct answer. Then here it is asked to find the inverse of the matrix this. So we know that inverse of the matrix, that is equal to adjoint of A divided by the determinant of A, adjoint of A by the determinant of A. Now adjoint of A means the transpose of the cofactor matrix. Transpose of cofactor matrix, that is, so this is A11 and A12, then A21 and A22, where Aij is the cofactor of the element Aij, where I can say Aij is what? Aij is the cofactor of the element Aij. So Aij is defined as, that is -1 whole power I plus j into Mij, where Mij is called the minor of the element Aij. So here, and minor of the element Aij, how to find? Simply we have to exclude the ith row and the jth column, and we have to take the determinant of the remaining part of that matrix. Okay. So here, so first we have to find the determinant of the matrix A, where matrix A is given, that we have to find, where the matrix A is given as cos 2 theta minus sin 2 theta and sin 2 theta into cos 2 theta. So therefore, the determinant of A, that is equal to the determinant of cos 2 theta minus sin 2 theta and sin 2 theta, then this will be cos 2 theta. Okay. So this will be equal to, then we can do the cross multiplication. So this will be cos square 2 theta and plus sin square 2 theta. So this will be obviously equal to 1. So the determinant is 1. And therefore, similarly, therefore, this is cos 2 theta minus sin 2 theta, then sin 2 theta and cos 2 theta. Okay. So therefore, first we have to find A11. A11, first we have to remove the first row and first column. So that will be cos 2 theta. And similarly, A12, that is, we have to remove the first row and the second column. So that is, and minus I have to keep. So that will be minus sin 2 theta. Since -1 whole power 1 plus 2 will be minus only. -1 only. Okay. So then similarly, A21 means it is -1 whole power 2 plus 1 and into M21, which is second row and first column we have to exclude. And this will be minus sin 2 theta. So that will be minus of minus, that is plus. So this will be sin 2 theta. Similarly, A22, so that will be second row and second column we have to remove. So that is cos 2 theta. Here we took plus only, since y -1 whole power 1 plus 1, that is plus 1. And here also -1 whole power 2 plus 2, that is plus 1. -1 whole power any even number, that is plus 1 only. And -1 whole power any odd number, that is -1 only. Okay. So therefore, the adjoint of this matrix A, so that will be, and that will be same as the A inverse also. A inverse also, since why here the determinant of A, that is equal to 1 only. So that will be equal to the A11 that is cos 2 theta, and then A12 that is minus sin 2 theta, then A21 that is cos 2 theta, sorry, sin 2 theta, and this is cos 2 theta. So this is nothing but the transpose of the matrix A. So that is option 4. So option 4 is the correct answer. Okay, so here it is told that if omega is a complex cube root of unity, then this value is equal to, okay, omega is a complex cube root of unity. So now we know that omega is the root, omega is one of the roots of the equation x square plus x plus 1 equal to 0, and omega cube that is equal to 1. So the cube root, so omega cube that will be equal to 1, and omega square plus omega plus 1 that will be equal to 0. So therefore the determinant of 1 omega omega square, then omega omega square 1 omega square 1 omega, the determinant of this we have to find. So then what we can do, we can add the elements of the first column, second column, and third column. Means I can write C1 goes to C1 plus C2 plus C3. So we are applying this column operation. So then we will get that is equal to the determinant of 1 plus omega square, then omega omega square. Then here also I will get 1 plus omega square, then omega square 1. This will be also 1 plus omega square, that is equal to 1 and omega. So that way, now this value is 0 only. So this will be 0 omega square, then 0 omega square 1, this, and this will be 0 1 omega. So here all the elements in the first column are zeros only. So therefore the value of this determinant, the value of this determinant will become 0. So option 3 is the correct answer. Then the solutions of the equation these are, we have to find the solution of this. So this is, we have to find the solution of the equation, the determinant of x 2 minus 1 2 5x, then minus 1 2x, that is equal to 0. So if we expand this determinant, then we will get, that will be, if we expand this determinant along the first row, then we will get x into, so plus minus plus, so x into 5x minus 2x, minus 2 into, I can write, then 2x minus 2 into 2x minus 2x minus of minus x, so that is plus x, then minus 1 into 4 minus of minus 5, that is plus 5, will be equal to 0. So this will be equal to x into 3x, that is 3x square, and this will be minus 6x, it is a 6, okay, then minus 9, that is equal to 0. So this we can write x square, 3 I can take as common outside, so x square minus 2x minus 3, that is equal to 0. So then if we factorize it, then we will get x square, then we will get what, x minus 3 into x plus 1, that will be equal to 0. So then it means that x can be equal to 3 or minus 1. So option 1 is the correct answer. Then here it is told that, if the matrix A, that is 3 5 2 0, and B, that is equal to 1 17 0 minus 10, then the determinant of A B is equal to how much? So we know that the determinant of A into B, that is equal to the determinant of A into the determinant of B. So therefore the determinant of A, that will be equal to 3 into 0, that is the determinant of 3, 5, 2, 0, it will be equal to 3, that is equal to 0 minus 10. 0 minus 10, so that is minus 10, and the determinant of B, that is the determinant of 117, 0 minus 10, so that will be minus 10 minus 0, so that is also minus 10. So this will be minus 10 into minus 10, so that is equal to 100. So option 2 is the correct answer. Then here we have to find the inverse of the matrix A, which is given as 5 minus 2 3 1. So therefore we know that in A inverse, that is equal to the adjoint of the matrix A divided by the determinant of A. So now therefore here the determinant of A, that will be equal to the determinant of 5 minus 2 3 1. So that will be 5 minus of minus 6, so plus 6, so 5 plus 6, that is 11. And therefore the adjoint of the matrix A, that is given as the transpose of the cofactor matrix, that is given as A11, A12, A21, A22, where Aij is the cofactor of the element Aij. So so now therefore here A11, that will be equal to we have to remove the first row and first column, so that is 1. And similarly A12, that is minus 1 whole power 1 plus 2, that is minus, and then we have to remove the first row and second column, that is minus 3. Then similarly A21, that is minus of second row and first column we have to remove, so that is minus of minus 2, that is 2. And similarly A22, that is second row and second column we have to remove, so that is 5. So therefore the adjoint of the matrix A, that is equal to 1 minus 3, then 2 and 5. Okay, so therefore the A inverse, the inverse of the matrix A, that is equal to 1 by 11 times 1, 2 minus 3, 5. 1 by 11 times 1, 2 minus 3, 5. So option 1 is the correct answer. Then here it is told if the matrix A, that is equal to 1 minus 2, 1, 2, 1, 3, and B matrix, that is equal to 2, 1, 3, 2, 1, 1. So then AB transpose is how much? AB transpose. So we know that AB transpose, that is equal to B transpose into A transpose. So therefore B transpose into A transpose, that will be equal to B transpose is obviously we have to convert the columns into the rows. So this will be 2, 3, 1 and 1, 2, 1 into, that will be A transpose, that is 1, 2 minus 2, 1, 1, 3. Okay, so this will be, so this is a matrix of the order 2 cross 2 rows 3 columns, 2 cross 3, and this is 3 rows 2 columns, so 3 cross 2. So the answer will come 2 cross 2. So this will be this into this, so this is 2 minus 6, 2 minus 6 plus 1, then this will be this into this, first row into second column, so this is 2 to the 4 plus 3 plus 3. Then second row into first column, so that is 1 minus 4 plus 1, and second row into second column, that is 2 plus 2 plus 3. So this will be equal to, this will be 3 minus 6, that is minus 3, 4 plus 6, that is 10, 2 minus 4, that is minus 2, 4 plus 3, that is 7. So 3 minus 3 minus 2, 10, 7. So option B is the correct answer. Then here it is told, let M be 2 cross 2 symmetric matrix with integer entries, then M is invertible if. So here, so symmetric matrix means what? If A transpose equals to A, then it is called as a symmetric matrix, and it has integer entries only, and it is a 2 cross 2 matrix. So that is integer entries. So I can say like this is A, B, C, D, and A, B, C, D all are integers, and A is invertible. Invertible is a symmetric matrix. A transpose is equal to A. So A transpose is A means therefore A will be equal to the A transpose, that is A, C, B, D. So it means that B should be equal to C. B should be equal to C, obviously. Invertible, it means that the determinant of A should not be equal to 0. So the determinant of A, so here B should be equal to C, so I can say A, B, B, D like this. A, so the determinant of A, that is equal to AD minus B square, so that should be not be equal to 0. So here, so if I take so AD, it is A transpose equal to B, it is invertible. It is, so it means that A inverse exists if the determinant of A is not equal to 0. It means that AD should not be equal to B square. So it means that so if I take B as 0, then and if I take, and I can take A equal to D also, so then the matrix M will be, the matrix M is actually M. M should be of the form A0, 0A. So it should be a diagonal matrix with non-zero entries in the principal diagonal, since A square should not be equal to 0. Since why? The determinant of M will come A square. The the determinant of M will come A square, and that should not be equal to 0. Then only it will be invertible. So option C is the correct answer. Then here it is told if A and B are matrices of order 3 and the determinant of A that is equal to 5 and the determinant of B that is equal to 3, then the determinant of 3AB, that is how much? So that will be equal to 3 power n times the determinant of A times the determinant of B, where n is the order of the matrices. So that is 3. So this will be 3 power 3 into 5 into 3. So that will be 3 power 4, that is 81 into 5. So that is equal to 405. So option B is the correct answer. So then Here it is told that if A and B are invertible matrices, then which of the following is not correct? If so, A plus B whole inverse is not obviously same as B inverse plus A inverse. So option D is the correct. So option D is the wrong statement. So it is the correct option. Here it is told if the function f of x is given as the determinant of cos x 1 0 0 2 cos x 3 0 1 2 cos x, then the value of the limit extends to pi f of x, that is how much. So now f of x, if we expand this along the first column, then we will get, it will be cos x into 2 4 cos square x minus 3. So this will be 4 cos cube x, 4 cos cube x minus 3 cos x, which is obviously equal to which is obviously equal to cos 3x. So f of x is nothing but cos 3x, and that we have to find the limit x tends to pi. So we can put x equal to pi here. So this will be cos 3 pi. So that is same as cos pi, which is equal to minus 1. So option A is the correct answer. Then here it is told that if x cube minus 2x square minus 9x plus 18, that is equal to 0, and then A is equal to the determinant of 1 2 3 4 x 6 7 8 9, then the maximum value of A is. So this, if we expand it along the first okay, if we expand this along the first row, then we will get, expand the determinant along the first row, then we'll get 1 into 9x minus 6 is 48, then minus 2 into, then 4 9 is 36 minus 42, and plus 3 into 4 is 32 minus 7x. So that will be equal to 9x minus 48 minus 2 into, this will be minus 6, then plus 3, so that is 64. So that is 9 6 96 minus 21x. So this will be equal to so 96 minus 48 plus 2 6 are 12, then plus 9x minus 21x, so that is minus 12x. So this will be equal to, so this will be equal to 96 minus 48 is 48, 48 plus 12, that is 60, 60 minus 12x. So A is equal to 60 minus 12x. We have to find the maximum value of A, that we have to find if this is given. So first we can, from here we can find the values of x. So here we can see that x cube minus 2x square minus 9x plus 18 equal to 0. So if we factorize it, then we will see that if we put x equal to 2, okay, here we can write, see, this is x cube minus 9x, then minus 2x square plus 18, so that is equal to 0. So then we can take x square as common, x as common, then this will be x square minus 9 minus 2 into x square minus 9. So this will be equal to x minus 2 into x plus 3 into x minus 3. That is equal to 0. So it means therefore x will be equal to 2, 3 or minus 3. So 2, 3 or minus 3. So then we have to find the maximum value of A. So therefore if x equal to 2, then the value of A, that is how much? A is equal to 60 minus 12x. So 60 minus 12 to the 24. 60 minus 24, that is equal to 60 minus 24, that is equal to 36. And if x equal to 3, then A will be equal to 60 minus 12 is 36, so that is equal to 24. Okay, and if x is equal to -3, then a will be equal to 60 minus 12x, so 12 3s are 36, so plus 36, so that is 96. Okay, so therefore obviously, okay, here there is some problems. 1 second, just okay. So here we can see that so therefore x square minus 2x square minus 9x minus plus 18, that is equal to 0. So therefore from here if we solve it, then we will get x equal to 2, 3 and -3. So for x equal to -3, we saw that a will have the maximum value, which is 60 plus 60 minus 12 into -3, which is 96. So therefore the maximum value of a is 96, which is option A. So option A is the correct answer. So the remaining questions we shall solve in the next part of this chapter. So hope all of you have understood these questions on the previous year KCET exam. So still any doubts if you have, then please write that in the comments section. We shall obviously clarify them in the subsequent videos. And please install our Sapience Education application, whose link has been provided in the description, where we shall upload some important previous year KCET, important homeworks which are based on the previous year KCET exam. So thank you everyone. Bye.